Hello there, Mr. Sutton here, bringing you the Algebra 2 Chapter 6 Quiz 2 Review Solutions on Exponential and Logarithmic Functions. For this problem, they want us to expand this logarithm, which means that we should have at most one variable or constant inside each log. So the way we're going to do this using some log properties, our top level thing that's going on is we've got some division. Logarithms turn division into subtraction. So we can rewrite this as log of x squared minus log of y to the fifth. And at this point we can't have these exponents inside, so we're going to use our pop-out rule of logarithms where we turn exponents into multiplication. So this first logarithm we can rewrite as 2 times the log of x, and this will be minus 5 times the log of y. For this problem we're trying to solve this exponential equation. Since 49 and 1 over 7 are both powers of 7, we can use the common base method on this one. To use that, though, we'll first have to rewrite these both in terms of that common base of 7. So 49 I can rewrite as 7 squared, and 1 over 7 I can rewrite as 7 to the negative 1. And notice that the original exponents are still there. At this point now I'm going to simplify the exponents so that I can have just 7 to one group of things. So we have to multiply the exponents to simplify these. So this is going to be 7 to the 2x minus 6. We're going to have to distribute that exponent. And distributing this negative 1 over here, we have 7 to the negative 2x plus 9. Now I can cancel out those common bases of 7, and this just leaves me with 2x minus 6 equals negative 2x plus 9. And at this point it's just a regular linear equation that I can solve. Let me just get all the x's on one side, constants on the other. So if I add this 2x over to the left, that's going to be 4x over there. Adding the 6 to the right gives me 15. And then dividing at the end, we end up with x equaling 15 over 4. In order to solve this equation, one thing that we could do that would help us out would be to at least isolate this exponential term here. So we'll divide both sides by 77. And I'm not going to bother reducing or making it into a decimal over here. I'm probably going to end up using the calculator anyway. So at this point, I have to decide if I'm going to use logarithms or common base method. And if I'm being honest, 5 and 278 over 77 do not appear to have a common base. They don't look like they're powers of the same easy number. So I'm going to go to logarithms on this one. I'll take the log of each side of the equation. On the left side, using the pop-out rule, that gives me x times the log of 5. And on the right side, I just have log of 278 over 77. To get x by itself, now I'm going to divide both sides by the log of 5. And now it's definitely time for the calculator. So on my calculator, let me make a fraction. And I'm going to do log in the numerator, and I'll need another fraction there. So I'll do a parentheses and then fraction. We need 278 over 77, just 77. Close that, and then come down here, and we need to do log of 5 in that denominator. And all of that comes out to about 0.798 if I round that off. To solve this logarithmic equation, I have to first get at most one term on each side of the equation. On the left side, I have these two logarithms. So I'm going to try to merge those together. Since I'm adding these logs, that means I can multiply their inputs. So I can call this log base 6 of 7x. And at this point, I'm going to get rid of the logs by raising the base of 6 to both sides of the equation. Or you could put it in exponential form. That it all accomplishes the same thing. So I'm going to have 6 to the left side equals 6 to the right side. On the left side, the 6 and the log 6 cancel out, leaving me with just 7x, which is nice. On the right side, 6 to the third, I believe, is 216. And then to get x by itself, let's just divide by 7. And I'm pretty sure that 216 is not divisible by 7, so that might be our final answer. I do need to check and make sure if I plug this back in that it doesn't make me take the log of a 0 or a negative. If I plug this back into the original equation, I've got log of this positive number, which is perfectly fine. I'm not taking the log of 0 or a negative. So this doesn't make anything undefined, and that means that this is our final answer for this question. To solve this logarithmic equation, let me first make sure that I've got at most one term on each side, and I do, and each of them is a log. So at this point, I'm going to raise the base, in this case that's 2, raise the base to both sides. So I've got 2 to the left side equals 2 to the right side. And the benefit of doing this is that the base 2 and the log 2 are going to cancel out on each side actually. So this is going to be x plus 4 equals 5x plus 24. And at this point I can just solve this like a regular equation. So let me subtract 5x from both sides. That gives me a negative 4x on the left. On the right side, if I subtract 4, I've got a 20 over there. And then dividing, we end up with x equals negative 5. But we always have to double check and make sure that this doesn't cause us to take the log of 0 or a negative number. So back in the original equation, if I plug negative 5 in for this x right here, negative 5 plus 4 gives me a negative 1, which is not an acceptable input for a logarithm. It also messes us up over on the second one. We'd have negative 25 plus 24 also would come out to negative 1. So because negative 5 makes this original equation undefined, I have to cross that off as an answer. Since there's no other answers, that means we actually have no solution to this equation. For this problem, they're asking for an exponential function that passes through these 2 points. So the way we're going to do this is we're going to use our standard exponential form of y equals ab to the x, which in this case I'm going to rewrite as ab to the x equals y. The reason I'm doing it that way is we're going to plug both of these points into this form, and that'll give us 2 equations that we can then solve to get the a and the b value that I ultimately need to finish this form. So I'm going to plug in my second point first, just because of the order that I'm going to be doing things with these equations. So I can write ab to the third equals 375. And then I'll do the same thing for my first point. ab to the first equals 15. Now I'm going to divide these equations. That allows me to cancel out the a values. I end up with b cubed minus 1, so that's going to be b squared on the left side. And on the right side, whatever 375 divided by 15 is, let me look that up. So 375 over 15 gives us, 25. Well, that works out. So if b squared equals 25, to get b I just need to square root 25, which ends up giving me 5. Now you might wonder, well, what about the plus or minus that I get when I take the square root of an equation? Well, since we're using this b value in an exponential function, we're not allowed to have negative b values in exponential functions, so we'll just leave the positive and forget about the negative. I do need to find the a value still, though. So to do that, I'm going to plug this b value of 5 back into one of these equations. Either one will work, but I think this second one with the b to the first power is going to be a little bit more manageable. So I'm going to have a times 5 equals 15, and then we can just easily divide both sides by 5 to get 3 for my a value. Plugging that back in now, we have y equals 3 times 5 to the x power, and that is our exponential function.